Hello data enthusiasts, and welcome to this channel where data is made fun and easy to understand, especially for non-tech people. My name is Katya, and after 10 years of teaching career, I leaped into this amazing world of data. And if you are interested in this journey, you can check my other video. You'll find the link in the description below. And today we are going to talk about something super essential in data analytics. Probably this is something that you are going to use almost every day in your career. And I'm talking about measures of central tendency. And I'm here to break it down for you and also to give you real life examples to show you how this concept could be applied to the business world. So let's begin. What is measures of central tendency? First of all, these are descriptive statistics tool. They help you to identify the central or typical value in a dataset. They're very good for compressing, for summarizing a large dataset into a single representative value. And usually the single representative value indicates the dataset's middle or average point. So just imagine you as a company, for example, you might have millions of consumers. So in order to get some understanding of the middle or average value in the data set, that's when you're going to utilize measures of central tendency. There are three measures of central tendency we are going to talk about. This is mean or average, this is median or middle value, and mode or the most frequent value in the data set. I'm sure you have heard about mean, you've used it a lot of times. So mean is the arithmetic average. It is the most commonly used measure of central tendency, and how we calculate it is we add up all the values in the dataset and divide by the number of these values. And since there is mathematical operations involved, this is only used for quantitative, or in other words, for numerical data. So now let's look at the example that we have here. Let's imagine we work for a company that has a loyalty club. Basically, consumers do some actions, and for each action that they do, they accumulate points. And let's imagine that in our company we have 20 members, 20 consumers, and this is the data that we are going to work with. We have the loyalty number of each of the consumer and the number of points each of these consumers accumulated in the loyalty club. And the question is to understand the average. Basically, to answer the question, what is the average number of points accumulated by all of the consumers that we have? And we have 20. So what we need to do, we take all the points here and we sum up all the values. So 152 plus 203 plus 120 plus 570 and so on and so forth. So we get as a sum 4,484. And then we divide by the number of values. If we count here, we have 20. So we divide by 20. And what we get is 224.2 points. So we can answer that on average, our consumers have accumulated 224.2 loyalty points. However, not everything is that easy and simple with the mean. Even though means are most often used in data analysis, they have their own limitations. Means are highly sensitive to outliers or extreme values that can skew the mean. So let's look at the example. This is on the left, this is the data set we have just looked at. We know that the sum is 4,484, number of observations 20, and the average number of points accumulated is 224.2. However, now I'm going to change the last value. Instead of 383, I'm going to use 3,500. I'm going to sum up once again all the values. This time I get 7,601. I still divide it by 20. And this time, since my sum has increased, I have 380.05 average points accumulated. And now I see that this value is not actually representative of all the values in my data set, because I have a lot of values that are far smaller than this 380, right? This is smaller, 60 is very small, zeros, 123 is super small, 114, 150. So I understand that this outlier, which is far away from all the other observations, it actually skewed my mean. My mean has become bigger. So this outlier dragged the mean to its direction. This is actually super important. When you do your analysis, you need to understand if you have these outliers. So the first question you need to answer, whether you have outliers or not. And the second question you need to understand is what is the reason for these outliers. Is it because you have bad data? Then you can simply remove these outliers. Or is it really the true observation? So for example, I might really have a consumer who has accumulated 3,500 loyalty points. Then I need to think what to do with this one. In this case, probably it is better to complement mean with other measures of central tendency, such as median. Median is the middle value in a data set. What we do in order to find the median? First of all, we need to order all our observations from the smallest to the largest. So here you see this is our data that we have just worked on, and I've just ordered them from the smallest to the largest. And then you need to find the middle value. If you have an odd number of observations, this will be your median. If you have an even number, then you take two middle numbers and you just calculate their average or their mean. So let's look at our example. We have 20 observations, we know this. So this is an even number. So we are going to take observation number 10 and observation number 11. The value here is 203 and the value of the 11th observation is 203 as well. This is 203 plus 203, 406. Divided by 2 is 203. So we didn't need to make all these calculations, of course, because here it's obvious it's 203. But just to illustrate once again how median is calculated when there is an even number of observations. A median is less affected by outliers compared to the mean. So when you have outliers, when you have skewed distributions, then it's better to use median. So for example, if here instead of 570, I had 526,526, this would not change my median, right? Because this is here, so I don't care about this one. I care about these two middle values in my data set. Since we started talking about skew and outliers, let's dig a bit deeper into the topic. What is skew? Skew is the asymmetry of a distribution around its mean. These are distributions in these pictures. First of all, let's talk about zero skew distribution. You see here that the mean is equal to the median and to the middle value. And all the observations are equally distributed around the mean. So there is no asymmetry. This is zero skew, and this is a property of a normal distribution. However, if we look at this distribution, what we see is to the right, we have a tail of outliers. There are these extreme values that are to the right. This type of distribution is called right skew. It is also called positive skew because this tail of outliers, these outliers are on the positive side. They are greater than observations here, right? So it is a positive skew because they skew our mean to the positive side. It becomes bigger. Our mean becomes bigger than the median in this case. Because remember, I've already mentioned that mean is very sensitive to outliers. So if there are outliers on the positive side, to the right, then mean will tend to be dragged also there. It will also tend to become greater, bigger. And if, for example, we have outliers on the left, so there is a tail of outliers to the left. This is a left skew. This is a distribution that has a longer left tail. So this is a negative skew also, because these outliers are on the smaller side. So they will drag the mean here. And now mean will be smaller than the median, right? Because outliers are here. They attract the mean, they drag the mean to their side. And mean is very sensitive. So it tends to move to the direction of the outliers. And the last part is the mode. Mode is the value that appears most frequently in a data set. A data set might have one mode, then it's unimodal. It might have more than one mode. If two, it will be bimodal. If more, it can be multimodal. There might be cases when there is no mean at all, no mode at all. That's also possible. Let's look now at our example. This is actually not a very good example. I'll tell you later why, but still, let's have a look. I again have my values sorted, and now I'm trying to see what are the values, number of points accumulated, that I see most often here. So these two consumers have 0 and 0 points, these two 203, 203, and these two 424, 424. So I could say that I have 3 modes. But usually we don't do it for numerical values. It's okay when we have 20 observations. Can you imagine if you have 1 million? So this actually doesn't make sense. What you do instead is you create a frequency table. So you put all these observations in bins. That's what I have done. I created my first bin where I counted how many consumers I have with points accumulated from 0 to 100. And let me just remove this one so that you can see it better. And this is 1, 2, 3, 4, 5. Sorry, I've done too many. This is 1, 2, 3. This is my first bin. I have 3 observations here. Then 101 to 200. 1, 2, 3, 4, 5, 6. This is my second bin. I have 6 observations here, and so on and so forth. So I created my frequency table, and now instead of mode, I'm going to look for a modal class. This is the group with the highest frequency. After I created this frequency table, I can turn it now into a histogram. On the x-axis, I will have the values of the bins. Yeah, so these are these bins that I put here. Let me again clean it a bit. I like to draw a lot. This is here your x-axis, and this frequency is actually here your y-axis. You look at the first bin, 0 to 100, you have 3 observations. So this is 3. 101 to 200, here you have 6, and so on and so forth. A histogram is a nice way to visualize this frequency table, and you can see that this is your modal class, because this is the bin that has the highest frequency of observations, 6. So this is how you use measures of central tendency. I hope that was clear. Remember that mean is most frequently used. However, it's very sensitive to outliers. You need to be aware of the outliers. You need to understand the reason why you have these outliers and probably remove them. Or if you cannot remove them, you probably need to consider median. And also you have mode. Mode is useful for analyzing categorical data, especially. If you have numerical values, you could put them into bins. And this is also a good way to represent your data. And there's one more thing that I wanted to mention about mode. If you have two bimodal distribution or multimodal, it might suggest that there are other variables that influence your mode. For example, if here we had observation like this, and let's say here this bin would also be, we'll have a frequency of 6. This will be a multimodal distribution. So we could assume that there is one more variable that influences this. Probably these are silver tier consumers of the loyalty club, and these are probably gold consumers here. So there is probably something else that we can dig deeper and we can understand what causes this bimodal distribution to appear. So this is just like an additional insight, because it's always nice to dig deeper. It's always nice to understand why you see what you see. That's what makes a good data analyst. So that's all for now. Let me know if you have any questions. Let me know if that was useful, and see you in our next lectures.